Hello there, this is Coach Ikram, and welcome to this video on acids and bases. We're going to start by talking about the self-ionization of water. So if you have any sample of water, small but equal amounts of H plus and OH ions, hydroxide ions, will form, and those create conjugate pairs. A conjugate pair is when you've got a hydrogen ion that is moving between two things. This is going to be called the self-ionization of water, and it means exactly what you think it means. It is water being able to ionize by itself. And so if you see down here, we've got two water molecules, and those water molecules are essentially reacting with each other in equilibrium here to form hydronium ion and hydroxide ion, and they're doing that by one of the hydrogens moving from one water molecule to the other. When water forms these hydronium or hydrogen plus ions and hydroxide ions, it's going to do them in a 1-to-1 ratio. They are equal ratios. And both of them are going to be equal to 1.0 times 10 to the negative 7 for their concentrations in neutral water. So this means if you've got in neutral water equal concentrations of H plus and OH, and they both equal 1.0 times 10 to the negative 7th, that's neither going to be an acid nor a base. But if you take an acid and you add the acid to the water, then the hydrogen plus concentration is going to increase. And therefore, the hydroxide concentration must decrease. Likewise, if you take neutral water and you add a base to it, your hydroxide concentration is going to increase, and therefore, your hydrogen plus ion concentration is going to decrease. This is an inverse relationship between hydrogen and hydroxide. So when H plus dominates, the concentration of hydrogen dominates, you have to have an acid. And if a base is dominating, you're going to have hydroxide, greater concentration of hydroxide. Because of this, if you take the concentration of the hydrogen and the concentration of the hydroxide, and you multiply them together, you're actually going to get this value, 1.0 times 10 to the negative 14th molarity. And this value is Kw. It's the ion product constant for water. And it should make some sense. If we said that we have in neutral water H plus concentration, which is 1.0 times 10 to the negative 7th, and hydroxide concentration, which is also 1.0 times 10 to the negative 7th, and you multiply them together, you're going to get 1.0 times 10 to the negative 14th. And the molarity here is squared, which we don't actually see very often, but it's just to show you that if you take two molarity units, you're going to get molarity squared. Using these values, we can actually rearrange them to solve for either my hydrogen ion concentration or my hydroxide concentration. And what I've done here is taken Kw equals hydrogen plus times hydroxide, and I've rearranged it so you can either solve for your hydrogen plus concentration or your hydroxide concentration. And this right here should read 1.0, and this one should also read 1.0. I can rearrange both to solve. So for example, if I'm given my hydroxide concentration is 2.5 times 10 to the negative 5th, and I'm trying to calculate my H plus concentration, I simply rearrange my equation for Kw to solve for H plus. So my hydrogen plus concentration is going to equal 1.0 times 10 to the negative 14th. And I'm going to divide that by 2.5 times 10 to the negative 5th, which is my hydroxide concentration. And when I plug that into the calculator correctly, using correct scientific notation, I'm going to end up with 4.0 times 10 to the negative 10 as my final answer. Likewise, I can do it the other way. If I'm given my hydrogen ion concentration, I can calculate my hydroxide by simply rearranging it the other way. So I'm going to go ahead and take my 1.0 times 10 to the negative 14th. And in this case, I'll divide it by my hydrogen ion concentration. And I get a hydroxide ion concentration of 1.12 times 10 to the negative 13. So if you have an acid, that means that your concentration of hydrogen ions is going to be greater than your concentration of hydroxide ions. So therefore, your concentration of the hydrogen plus ions is going to be greater than that 1.0 times 10 to the negative 7th molar, because 1.0 O times 10 to the negative 7th was what it was when it was neutral. And now in an acid, it's going to be greater. In a base, the opposite is true. The OH concentration, the hydroxide concentration, will be greater than the 1.0 times 10 to the negative 7th. So if we're looking at these down here, my hydronium concentration is 1.0 times 10 to the negative 3. That means that's going to be acidic. If hydronium is 1.0 times 10 to the negative 11th, that's going to be basic. And if my hydroxide concentration is 1.0 times 10 to the negative 4th, that's also going to be basic. Now we're going to talk about pH, and pH is a scale that we're going to use to determine whether or not something is acidic or basic. And it's on a scale of 1 to 14. If it's right in the middle here at 7, it's going to be a neutral solution. If it's between 0 and 7, it's going to be acidic, and if it's between 7 and 14, it's going to be basic. The pH range is from 0 to 14. Again, pH from 0 to 7 is acidic, 7 is neutral, and 7 to 14 is basic. When we calculate pH, we're going to use the hydrogen plus concentration and the log key to generate pH. And pH is a base 10 logarithm, and we do this to work on the whole number scale. If you look over here on the right, we do have a depiction drawing that kind of shows you how this all works. So if we've got neutral and a pH of about 7 here, we've got equal amounts of the hydroxide ions and the hydrogen plus ions in concentration. In an acidic solution, when the pH is less than 7, you'll notice that we've got more hydrogen ions in concentration or in solution. And then if it's basic, down here towards 14, you'll notice that in my solution I have more hydroxide ions than I do hydrogen plus ions. When we're talking about the pH scale, we're talking about logarithms, and a logarithm is the power to which 10 must be raised in order to create a certain number. And in this case, our power is going to be pH or POH. So if I've got log base 10, 10 to the y to some sort of exponent, if I take the log base 10 of that exponent, it's going to pull it out. So for example, the log of 1.0 times 10 to the first is simply 1, or the log of 1.0 times 10 to the negative 5 is negative 5. pH is a negative log because the value for this is very, very small and thus is going to have a negative exponent, and we want our pH ultimately to be positive. And the formula that we're going to use to calculate our pH is thus. pH equals a negative log of the hydrogen ion concentration. So when we're solving this in our calculator, to convert from hydrogen ion to pH with any or most calculators, you're going to press the negative key, then the log, which you'll notice is right down here on our class calculators. And then you're going to have negative 5, okay? So negative log 3.09, and then negative 5. Make sure you put that in correctly for your exponent. And sometimes the log key is log base 10 as well on a calculator. In this case, you can see we've got an example of an iPhone calculator. Make sure you use the negative or the plus and minus key, not just the minus key when you're doing this. So you're probably wondering if we need to use Sig Figs when we're converting from hydrogen ion to pH, and the answer is yes, we actually do. So the number of Sig Figs and the coefficient of the concentration. So for example, if I've got 3.09 times 10 to the negative 5th molarity for my concentration, that total number of Sig Figs, which in this case is 3 Sig Figs, is going to end up being the number of digits to keep after the decimal in the pH. So if I took the negative log of 3.09 times 10 to the negative 5th, my pH then is going to be 4.510. I have to have 3 Sig Figs here after the decimal because I had 3 total Sig Figs in my concentration. So for example, if I'm finding the pH of my hydronium ion concentration is 5.0 times 10 to the negative 6th. Notice that we've got 2 Sig Figs here. So when I take the negative log of 5.0 times 10 to the negative 6th in my calculator, I'm going to end up getting 2 digits after the decimal, so it's going to be a pH of 5.30. POH scale is when we can examine the base ion concentration by calculating POH in the same exact manner of pH. It's essentially the mirror image. It's perfectly opposite. So POH range is also from 0 to 14, and it's going to fluctuate inversely with pH. So for POH, 0 to 7 this time is basic. 7 is still neutral, and then 7 to 14 is acidic. So again, it's the mirror image of what pH is. If you recall from earlier in the video, my hydrogen concentration times my hydroxide concentration equaled 1.0 times 10 to the negative 14th. Because pH and pOH are also inversely related, we can say that pH plus pOH is going to be equal to 14.00. So for example, if I've got a pH of 6 and I subtract that from 14, my pOH is going to be 8.0. Let me get a pen here. If I have a pH of 4.0, my pOH is going to be 10.0 by subtracting. 3.0 for my pOH gets me 11.0 for my pH. And 11.0 for my pOH gets me a pH of 3.0. And I did all of this by subtracting each of those from 14. If we're given pH or pOH, we can determine the concentration by using the inverse of the log. So we can go backwards. So to find the hydrogen ion concentration, we're going to set 10 to the power of the negative pH. And we're going to do the exact same thing for the pOH. But in that case, if we took the 10 to the negative pOH, we'd get the hydroxide concentration. We've got both of those laid out right here. So to convert from pH to hydrogen ion concentration with any calculator, so for example, if I've got a pH of 4.510, to solve, I'm going to find the hydrogen ion concentration. I take 10 to the negative 4.510. I'm going to push 10, then negative, and 4.510, then enter. And this is going to end up giving me 3.09 times 10 to the negative 5. And that also works out because if you note for Sig Figs, I've got three significant figures there, and I've got 3 after the decimal in my pH. That's all we've got. Hopefully you took good notes. Make sure you go back and rewatch the video as needed and come to class with questions. Thanks.